Hello, this is John from caveofprogramming.com. In this section we're going to start looking at C++ 11, and I'm going to start with something that isn't going to seem that useful, but is actually going to be extremely useful when we can see what you can do with it really in the next tutorial. So we're going to start by looking at decltype, or decltype if you prefer, and typeid. So decltype is a new C++ 11 keyword, and typeid is already present in C++ 98, but I wanted to go over them here because we're going to need them when we start looking at auto in the next tutorial, which is a C++ 11 keyword. So to use C++ 11, we need to enable C++ 11 in our compiler. If you're using, I'm not sure how this works with Visual C++, so you might want to Google for that, but I'm using GNU here, and we have to explicitly enable the C++ 11 extensions. So what I'm going to do is I'm going to go to Google here, and I'm going to type GNU. If I was using Visual C++, I'd type obviously Visual C++, GNU, and enable C++ 11. And let's try this first link here. And so here we can see that we need to add this flag to the compiler flags to enable C++ 11. So Eclipse is running the compiler behind the scenes. It's running a bit of software which you can also use on a command line, and it's supplying this as a command line argument to it, or it will do when we add it in the right place. So let's copy this, and again, you might not need to do this if you're using a really new compiler, but I do have to do it for this. So let's go to Eclipse and right click the project, and I'm going to go to C++ build, I think I need, and settings. Let's change this configuration up here to all configurations. That might be in a slightly different place for a different compiler. It doesn't matter too much. I just want to make sure if I build a release version of this, then we're also going to pick up that setting rather than just setting it for debug, which is the default, or release. Then I'm going to go to the GCC C++ compiler section, and I'm going to go to miscellaneous, and here we can add flags that are supplied to the compiler that compiles the program. So let's put a space and then add this flag and click apply. If we don't do this, we'll get warnings when we use C++ 11 constructs, and from my own experimentation, it seems that sometimes you'll even get an error and something actually will not compile unless you add that. Let's start by looking at typeid, which is present in C++ 98. Now, although typeid is a keyword, in order to make your program well formed and to be sure it will actually work as it's supposed to use typeid, you need to include the type info header. So let's put up here include type info. So you need to remember to use that if you're using typeid, although your program will often appear to work without it. Now let's declare something here, for example an int. I won't bother initializing it. We can then use typeid to interrogate this type and figure out what it is. And again, this is going to seem a bit useless when I show you this in this tutorial, but we're going to get on to see that this stuff is in fact it can be incredibly useful. Let's use CL. Let's say type ID, and we'll pass in that integer there. Excuse me. In fact, let's give this another name because, you'll see in a minute. So let's call this value, and let's pass in value there, and that's going to return us some kind of object that contains type information about this variable. So we want to get the name of this type. So I'm going to type .name and call the name function on this object, and then we're going to let's just output endler there. So if we run this, what we get is we get I, which indicates integer type. That's why I didn't want to call it I, because that would be confusing. but I actually means this is an integer. If we change it to a double like this, let's run this. At least for this compiler we get D. Let's try something a bit more complex. Let's try a string. So I've got IStream and namespace standard in there, and on this compiler I don't need to include string.h or anything. Let's run this. So we get something really complex here. And what's going on here is that if you write a C program using an actual C compliant compiler, you could use GCC with appropriate flags. So one that won't allow you to do C++ stuff, only C. What would C if we looked at the binary code of the program would be the actual names of functions and variables in there. Well, now that I think of it, I don't know whether we'd see the names of variables in there, but certainly for functions, we'd see literally the names of functions in our binary file. With C++, you can overload functions, and you can attach functions to objects, to classes, as methods. And that means that the binary file needs more information about the context of the function. It needs to know which version you're calling, if it's an overloaded function or you're defining. It needs to know, does it belong to a class? So C++ does this thing called name mangling, where it actually takes the names of things like variables and functions, and it adds a load of characters to them to indicate, to give more information about what those are. You know, which overloaded particular function are you dealing with? Does it belong to a class, etc.? And that's what's going on here. We're seeing name mangling, and so you could actually see this in the binary file, probably, depending on your compiler, probably prefixed by underscore z as well. And so this gives a lot more information about this actual type. It's not usually this nasty looking. String is a complicated class, and usually you'll see something a bit simpler than this if you try this on a class you've declared yourself, but it will still mangle the name. So using typeid, passing it our actual variable and then calling name on it, we don't get literally the name of the thing, but we get something that corresponds to the name. So you could work out that I meant int, D meant double, and here we can indeed see string. It's at least in there. Now, another thing that I want to show you in this tutorial, and we're going to come back to typeid in the next tutorial on auto, but I want to show you something that is C++ 11 specific. It's been added in version 11 of C++, 2011, and that's decltype. So this again is a keyword. It's an operator like size of, like typeid. Well, we've got string value though already, and what decltype, or decltype I should probably say, I think that's the widest used pronunciation. So decltype here, this actually allows us to declare variables of an existing type, or we could also, as we'll see in the next tutorial, we could use it to form a return type of a function. So if we type decltype value, because value is a string, this is just like typing string, so we can declare something else here. Let's say name, and then we can say name, well, we could do it on the same line, it doesn't matter. Let's say name equals Bob. Then if we do typeid name on that, we'll see that it's a string. And also, just for good measure here, I'm going to output it. So let's output name, and let's run this. And we see that we've got decltype has extracted the type from this variable value up here, which we didn't even bother initializing, although I could have done. And it said, okay, this is a string, so this now means string. It returns the type string, and we can use that even to declare variables of that type, the same type as this. And I've set that string equal to Bob. We've output the type information. Again, we can see that it's a string there. We've got name mangling going on here, and I've output the name that we set this variable to for good measure. So this perhaps seems a little abstract at the moment, but it's really worth trying this for yourself, because we're going to make use of these when we look at the very, very, very useful auto keyword in C++11. Remember, if you use typeid, you must include type info, otherwise the results are not guaranteed. And you can use decltype to declare variables of an existing type that you've used in your program. So do have a go at that, see what results you get. You might get slightly different name mangling with your compiler, but it's going to be something broadly similar. So well worth trying. Try out typeid and try out decltype, and then you'll be in a good position for when we look at auto in the next tutorial. So until next time, happy coding.